Hi, everyone. My name is Daniel Dadap. I'm an engineer on the NVIDIA Unix graphics team, and I'll be talking about switching dynamic display muxes. We can start with a little bit of background. If my slide will advance. I think I need to move my pointer on the screen. There we go. What is a dynamic display mux? Well, folks, we can pop the terminology stack there one word at a time and break it down, starting with mux, which is an abbreviation for multiplexer. It's a device that takes multiple inputs. It allows you to select one of those inputs to drive an output. On a display mux, the inputs are going to be connectors, display connectors on GPUs, and the output is a display device. And usually that's going to be on internal panels. It's going to be internal connectors for internal panels on a hybrid GPU system. Very rarely, we do have muxes for external panels as well. And in either case, you're generally selecting between an integrated or a discrete GPU as your input to drive that display device. And this is the sort of thing that you would typically configure at boot time. Maybe in your firmware setup screen, you'll make a selection for one GPU or the other, and that selection will persist for the lifetime of the boot. Unless you have a dynamic display mux, and those are display muxes that are designed to be switched while the output is actually being driven. You'll see examples of this in systems sold with NVIDIA Advanced Optimus branding. When you do have a dynamic display mux, there's a couple of things that you want to see for the best experience. One of those is panel self-refresh, so that you don't have blanking during the mux switch transition time. And the other thing that you want to see is you want to make that transition time as short as possible to reduce the effect of visible stuttering while you're switching. Let's take a look at some of the typical ways that muxes are configured. Here's a system with no muxes. That's the simplest configuration of all. And on this one, we have the internal panel is permanently driven by the integrated GPU. And we have an external panel that's, whenever it's connected, is always driven by the discrete GPU. If you add a mux to the internal panel, you can now select between either of those to drive the internal panel. You still have the external panel is fixed to a discrete GPU. And you can add an additional mux to also switch external panel. And you might be confused by the colors. These colors are chosen to represent your favorite GPU vendors. I've mixed them up on purpose just to kind of illustrate the possible diversity of configurations we have here. It's not exhaustive. Besides permuting the vendors a little bit more, you do have, for example, muxless systems where both the internal and external panels are always driven by the integrated GPU, and discrete GPU is not connected to anything at all. So if you have such a system, what do you do? Why even have a discrete GPU if you're not connected to anything? Well, that's where offloading comes into play. We're probably all familiar with display offload. This is where you have one GPU acting as a display offload source, creating a full screen frame buffer that then gets exported for another GPU to consume as a display offload sink. And the display offload sink then does the scan out even if it's not doing any rendering of its own. If we want to get a little fancier, we have render offload, where instead of exporting a full screen frame buffer, the render offload source GPU exports individual application buffers. Those application buffers are exported to the render offload sink, which combines them with other content to create the full screen frame buffer, and in a sane setup then scans that out. But of course, nobody's going to stop you from doing both at the same time and taking GPU1 as render offload source, sending application buffer to GPU2 as render offload sink, which then is also the display offload source going back to GPU1 as a display offload sink for scan out. And it's very tempting to say, that's silly, don't do that. But if you recall, we might have a system where we're forced to have different displays driven by different GPUs. And in that case, it's hard to avoid. We do have an optimization in the NVIDIA driver where for the special case of full screen render offloaded applications, we can avoid the round trip, but it is something that in general you have to consider as something that might need to happen. So how can Muxes help us with that? Well, the core benefit of having a Mux is that if you can switch what GPU the display is physically connected to, then you can completely avoid the need to do any kind of display offload. And if you avoid display offload, then you don't need to keep both GPUs powered on all the time, even if you're only rendering on one. And you also don't have to do a full screen copy over PCI Express all the time. If you have a laptop with a 4K screen at 120 hertz, those full screen copies can be pretty expensive. And that core benefit is possible if you have a display mux that's not dynamic. Of course, there is a convenience price. In the best case, you're going to have to end your desktop session and lose some state. In the worst case, you're going to have to reboot your system and lose some more state. So that's where dynamic switches come into play. And there's a few different ways that you could kick off one of those dynamic switches. Probably the most naive way is having it be completely explicit. And here's where you can imagine a control panel that has some kind of user interface element that lets the user, toggle on demand one GPU or the other. But we can also do implicit switching. And if you remember that special case for full screen render offloaded applications, that's kind of the poster child for implicit switching here. Because again, you have something that's being rendered on one GPU and then displayed on another. And in the full screen case, that basically collapses to display offload. But if you switch the mux, then you can take that display offload out and do direct scan out and get all the benefits of direct scan out. You could go fancier and even do switches while you're compositing applications that are being rendered on multiple GPUs. That's definitely possible. If you look at macOS and some of the MacBooks Pro that have dynamic display muxes already, it's something that's being done. But in any case, whatever your policy is for doing a dynamic switch, whether it be explicit or implicit or what have you, support is needed both from Wayland compositors and from the GPU drivers on both sides of the switch. If you're a GPU driver, you don't really care so much which of those use cases we're looking at. If you're a Wayland compositor, these are listed in roughly increasing order of complexity. And of course, for the GPU drivers, you're going to need some infrastructure to support all of that. Let's take a look at what happens during a mux switch. The first thing, of course, is the mux switch needs to be initiated. So that's going to, again, happen through one of those example policies, for example. And once the mux switch is underway, the GPU drivers on both sides of the switch are going to need to coordinate. The sorts of things they might need to coordinate on could be, for example, making sure that the brightness level stays the same across the switch. If you have brightness controlled independently by each of the GPUs, you might want to get that from the switch away from GPU and prepare the switch to GPU to make sure, and there could also be some translation of levels there. Another thing that we could be doing during this stage is remember that the GPU that's going to be switched to isn't actually connected to any display at this point. If you want to start preparing for the switch, here's where something like proxying, DP, DisplayPort, aux traffic could be useful to let the disconnected GPU utilize the connected GPU to prepare for the switch. Then panel self-refresh, we talked about that. That's going to make sure that we don't get blanking and instead have a hopefully very brief pause where we display the same image. The mux switch itself happens, and there's going to generally be a specific minimum amount of time that's dependent on the actual mux hardware itself before the link is usable by the switch to GPU. Once that time has elapsed, then the GPU that's been switched to can set a mode, and we can start rendering graphics, turn off PSR, and move happily on our way. So I did talk a little bit about we're going to need some infrastructure for GPU drivers in order to support this, besides the work in the GPU drivers themselves. What is that infrastructure going to look like? Well, it turns out we have something in Linux already. It's called vga-switcheroo. It's been with us since 2.6.34, so quite a while now. And on the surface level, it seems kind of perfect for what we need. It's got a concept of a Mux handler driver, which is going to be what's driving the actual Mux hardware itself, as well as client drivers, and those are going to be the GPU drivers. And they all register with subsystem, and once it has two clients and a Mux handler, it automatically turns on and exposes its functionality. And in a lot of cases, the client drivers, the client driver and a Mux handler are both registered by the DRM-KMS driver for one of the GPUs. There are optional callbacks that clients can implement to be run before and after the switch. Those can be used for the sorts of things I was talking about, for coordinating certain events during the switch process. And that looks great. Why don't we use it? Well, here's where we start running into trouble. And this is going to be kind of the source of a lot of our challenges here. In 2010, when vga-switcheroo was introduced, X did not support multiple concurrent OpenGL implementations. So there's some design fault from that and resulting functional challenges. And kind of the biggest one here is because you couldn't have more than one GL implementation working in X at the time vga-switcheroo was designed. The design assumes that you can't switch the Mux at all while you're driving the output. And that's sort of the whole thing of dynamic Mux switching, is we're switching while we're driving the output. In vga-switcheroo, if one of your client DRM-KMS drivers has a mode setting client ref count that's non-zero, you get no switch at all. Unless you force the switch, there is something called a Mux-only switch, which you can force a Mux switch even if otherwise the can you switch the Mux test fails. But if you do that kind of Mux switch, it bypasses the driver callbacks, and we kind of need those in order to do our coordination. Another functional challenge with vga-switcheroo is that there's only a single support for a single Mux, and can only have exactly two inputs going into it. If you have an existing system with multiple Muxes, they are out there, then all of the Muxes are driven together as a single logical device, even if the hardware might otherwise support individual addressing. And that's also a problem for dynamic Mux switching. Some of these functional challenges are reflected in the user space API. The big one, again, is this single Mux dual output assumption that's baked into the user space API. There's also no natural synchronization point between switching the Mux and doing kind of mode setting work. And another one, this is unrelated to the rest of the design, is that the user space API is in debugfs. And if your distro has disabled debugfs for security reasons, then you're out of luck and no vga-switcheroo for you. These challenges are not insurmountable. We could work through and add a new UAPI to vga-switcheroo that does not have those limitations. We could introduce a new type of Mux switch that doesn't check for mode setting clients, but still calls the callbacks. But there's another way forward that I think makes a lot of sense. I'm kind of going to try to make the case for, and that's using DRM-KMS instead. And why DRM-KMS makes sense here is because, again, when we're contrasting a dynamic Mux switch from a non-dynamic one, the difference is that in a dynamic switch, you're actively driving the output. And what's driving the output is going to be a DRM-KMS mode setting client. And that client is actually going to need to coordinate a lot of the stuff around the Mux switch anyway, So we might as well extend the DRM-KMS API to support dynamic mux switches. And this idea is kind of so intuitive that actually NVIDIA and AMD and maybe even others came up with it independently. There's a proposal a little under 2 years ago on the DRI development mailing list to that effect. And more recently, AMD had a proposal a few months ago at the DisplayNext Hackfest in Spain. And there's a couple of minor differences. I'm not going to go into detail about the proposals themselves, but broadly, everyone seems to agree. Fundamentally, DRM-KMS makes sense as a place to do mux switching. And kind of the core reason it makes sense, it has to do with the physicality of the mux itself. And if we go back to what's on the mux, well, what's on the mux is display connectors, and we have exactly an object that corresponds to that in the DRM-KMS API, which is DRM connector. And if we add connector properties to sort of map the relationship between these connectors and a mux on the system, and that's going to be just a really natural way for clients to discover the availability of a mux and to understand the relationship between connectors on different GPUs that are actually potentially driving the same display. So if we do mux switching in DRM-KMS and use the DRM-KMS user space API and extend it to do that, then it actually solves the problems we have with the vga-switcheroo user space API as well. One of the easy ones right away is that we don't depend on debugfs anymore. We depend on DRM instead, and DRM is a natural, sensible dependency. You can't really do any of this without DRM. And the big one also is because we're talking about things at connector level granularity, you can support any number of mux connectors on any number of muxes. And those muxes could also have any number of connectors on them. It doesn't have to be two. You definitely expand the space of hardware configurations that you can support. And we also eliminate the assumption that the connectors on the mux are going to be exactly one is a discrete GPU and one is an integrated. You might have other configurations. You might even want to mux connectors on the same GPU for reasons I'm not creative enough to imagine. And also, the compositor or other mode setting client might already need to do an atomic mode set. So you could make the mux switch request become part of that atomic mode set request. And also, with vga-switcheroo, we talked about there's no natural synchronization point. With DRM-KMS, you naturally synchronize things that are happening in the mux switch with events that the DRM-KMS client is actually driving. So there are definitely some open design questions. One of them is, and this is kind of the main difference between the AMD and NVIDIA proposals that we have here, is whether you want to have a dedicated mux class and a ioctl for some mux file on in sysfs versus setting connector properties and building that into your KMS atomic commit request. Another is you're going to need to do authentication across the devices. If you're doing the dedicated mux device, then you're going to need to prove that you have DRM master on both of the devices owning the connectors on the two sides of the switch. If you're going to be doing it as part of an atomic commit request, well, an atomic commit request, you only have one DRM device there, so you need to prove master on the other device too. Discovering the topology of the mux is another kind of open design question. It's really easy for the naive case of we have only an internal mux, which is going to be most of the cases, because you can just key off of whether you're looking at internal display connectors or not. But if we want to support other configurations, that's something that will probably need to be fleshed out a little bit more. We also need a way to query attributes on the connector that's not connected yet. I mentioned DisplayPort aux proxying as a possibility. Maybe there's other things that we could be doing too. And another open design question is how to switch a mux that isn't connected to any panels yet at all. So for an external mux, for example, you may want to switch it, and this would really only make sense for an explicit switch. And I should say too that explicit mux switches are really the only kind of switch that makes sense for external panels anyway, because with an external panel, you don't have control over things like how long the panel takes to recover from mode set. It could be on the order of seconds or tens of seconds. You don't want that kind of thing happening without the user actively being behind that decision. If we have a design where we're using a dedicated mux class and there's actually a separate, UAPI for the mux switching that's not part of doing, atomic commits, then that's probably a main reason to favor that design. Let's take a look just at how this would sort of be built across the stack. And starting from kernel space, obviously DRM-KMS is going to be central here. The GPU drivers on both sides of the switch are already DRM-KMS drivers. And we would have a mux handler driver analogous to the handler drivers in vga-switcheroo registering with DRM core as well. In this example, the mux handler uses ACPI to drive the actual hardware. That doesn't have to be the case. That's just an example here. Then the GPU drivers are going to export connector objects in user space, and here's where our properties come into play. These connectors are both saying that they are associated with mux number 0, and then they each have an index on that mux. And if we're doing a user space API where we're mux switching as part of an atomic commit request, then that's all you need. If we are also having a dedicated mux object, then that mux object is going to expose a file that's going to be part of the user space API as well. Then, of course, the compositor drives all that. And here again, I've got, just as an example, applications being rendered from multiple GPUs. Again, just to illustrate, this is potentially something that's got a lot of applications running on it, and the compositor is going to drive the policy based on what those applications are doing. And I guess it should be pretty self-evident that the compositor is the natural choice for driving that policy. Again, the compositor knows what all the applications are that are running, and from all the GPUs. And also, importantly, it has extra context that other layers of the stack aren't going to necessarily, that would help sort of break the tie on tricky situations. So my go-to example for this is, again, if we consider that full screen, unredirected, render offloaded application, and then you hit Alt-Tab, and now all of a sudden you're not really full screen anymore because you're partially occluded. And here's a place where the compositor could decide, well, if it can do rendered composition on that GPU, it can decide to do rendered composition for that Alt-Tab pop-up without switching the mux until that pop-up is dismissed, and then either you're back in full screen, in which case not switching the mux is the right call, or or you've gone to windowed mode or to some other application, and in which case you'd want to switch. Another example is desktop notification. Same idea. If something pops up, you're not really full screen anymore on that on that application. But in order to do this, we need more robust multi-GPU support from compositors. There's a couple of things that stand out right away, and the first big one is that the compositors are going to need to be able to directly scan out from any GPU on a multi-GPU setup. And this is actually useful even if you don't have a Mux, and if you're not planning on doing Mux switching at all. If you remember the Muxless system where we have different panels being driven by different GPUs, you're going to want to do this anyway. And there's a link later for a prototype implementation of that. Then the next step would pretty much be to do rendered composition on any GPU. And again, when the Alt-Tab desktop notification stuff, if you can do rendered composition there, then on all the GPUs, then you might not need to switch the Mux for that sort of thing. This is also useful even if you're not Mux switching, because it allows you to avoid that round trip case. If you can do rendered composition, always do rendered composition on the GPU that is actually connected to the display, then you will avoid the need to kind of do that round trip render and display offload dance. And another thing that could be helpful is tracking buffer residency as part of the DMA buffer protocol. That's just kind of nice information for the compositor to help make these decisions if it can easily know, which GPU owns which buffer, and more information to drive that policy. So there's, for a lot of the open design discussions, I think one thing that I would like to inform those design decisions is sort of what makes sense for the compositors. If you have kind of opinions on that, we can talk about that maybe in the hallway track. You can find myself or Austin, my colleague here, would be happy to talk about that. I know this is just a wall of links right now, but these touch on some of the things I talked about. Shout out to Mario at AMD for number 3 and 4, Austin for number 5, and Zaver, who's here as well, for number 6. That's it for the presentation. We have a couple minutes for Q&A if anyone's got any questions. Thank you.
I have a very basic question. So is there any hardware differences between like the normal Mux and dynamic Mux, or is the difference just firmware, software?
So the hardware is fundamentally the same, right? At a fundamental level, the non-dynamic Mux and a dynamic one can do, the same basic function, which is to switch the display. But yes, there's, at least for NVIDIA Advanced Optimus, there's tighter requirements on things like the transition time, and PSR is going to be a requirement for a system, and that'll goes to, making sure that you have a good user experience. I think there are systems out there which don't have things that were designed for dynamic Mux switching that you could probably do a dynamic switch on and maybe just have a suboptimal experience. But there are definitely also ones where the only way to flip it is at boot time. But the hardware itself would be fundamentally the same. Maybe the newer ones that are specifically made for dynamic switching are faster.
I see. Thank you.
Mm-hmm.
Yeah, I don't know if I haven't kept up with the Mux stuff in recent years, but I know back in the day when vga-switcheroo and stuff was added, that you used to be able to at least switch the Muxes on the like I2C and DP-aux channels independently. I don't know if that's something we might want to consider here, because rather than like proxying DP-aux, you could switch the Mux beforehand for that, query it with the other monitor to get ready so that you knew.
Yeah, so in vga-switcheroo they do have a concept of kind of a split switch. And that's where, for example, I2C might be muxed separately from the actual video signal. And yeah, vga-switcheroo has a bunch of machinery in place for that sort of thing, where you can say, okay, I just want to switch the I2C line for now, and then and then switch the display line later. That is not possible on all Muxes. So, but yeah, that's definitely for the sort of coordination aspect of it. That is another possibility. I think having the GPU drivers be able to coordinate more directly through DRM would help solve things for the more general case where you might have a monolithic mux that that can't switch those things independently.
Right.
Yeah.
Thanks.
Mm-hmm.
Hey, can you hear me all right?
Yeah.
So I'm just curious, muxless displays have traditionally been like a very significant pain point for like VFIO users, where if you want to like pass in a GPU to a Windows virtual machine, and then you shut down the virtual machine, and then the virtual machine, even though it's gone, you'll have your NVIDIA device driver still bound to VFIO PCI. I'm kind of curious, like, is this particular mode of transitioning back and forth between different muxes, do you see there being a potentially more elegant way of accomplishing that, like transitioning the GPU, not just between like which one is going to handle the display for rendering and which one is going to be doing 3D rendering, but maybe like going into virtualized environments and coming out of virtualized environments? Is there some way that we could like intermingle what you're doing with like the VFIO driver?
Yeah, I mean, for VFIO, it sounds more like the challenge has to do with kind of leftover state. Than what you're describing sounds more.
Yeah, it's like binding it in SysFS.
Yeah, I'm not sure if it would be as helpful. I mean, maybe just as a workaround, you could make sure that you've switched all the display outputs away from the discrete GPU, just so that there's nothing there for it to. But yeah, I'm not. Yeah, I'd have to think a little bit more about what the interplay would be there.
Yeah. I have one follow-up question, if that's okay. I'm not sure if you've seen the NVIDIA merge driver, but it's the driver that runs the NVIDIA vGPU Manager utility and the NVIDIA vGPU VFIO module next to traditional like KMS output and actually rendering with the PF. So it lets you have VFs and PFs adjacent to one another. So this is like the non-SRIOV mode, right? It's the 2080 Ti and prior. So that's when they had like VFIO MDEV and not SRIOV. In that case, you could use the host like for actually compositing the display and running virtual machines at the same time. And that's actually been done on laptops with like muxless laptops where the iGPU handles the display, and then the NVIDIA GPU can accelerate individual processes or individual virtual machines. I'd be kind of curious to see like maybe there's something there that could be done with KMS where we could control like more elegantly as well which of the processes get acceleration and which ones.
Yeah, I mean, I'm not too familiar with virtualization stuff, but it sounds like there may be some overlap between what you're describing and render offload.
Yeah. There's one project in particular I think you should take a look at. It's KMS render only, KMS RO, that lets the device file descriptor. I'll wrap it up quick. I know I'm going along with this one, but it lets the KMS file descriptor and the guest read and write directly to the display controller using a shared buffer. I just want to maybe show you that afterwards.
Yeah, I'll take a look at it. Thanks.
Okay, thanks.
Okay, thanks. I think that's the last presentation of the day. So sorry. Go ahead.
So I'm not sure if this is really related to muxing, but how do you deal? How big of an issue is the need to tile and detile the stuff off the NVIDIA GPU so that you can use it with the Intel or whatever the iGPU is can understand it?
So can you repeat the question? I'm sorry.
How big of an issue is the need to detile off the NVIDIA this stuff so that it can be understood by the other GPU?
Yeah, that's, I mean, I don't know if, James, you know more about how that offload stuff works?
Yeah, I think, yeah, we just have to, if we have a tile buffer that we're rendering from our GPU, we have to copy it to a non-tile buffer first before we can display it on another GPU. And usually that also takes care of copying it into a buffer that the other GPU that's driving the display or whatever, our display controller can read as well. So that's usually a step in render offload already. But yeah, that's one of the things we want to skip if we're doing direct scan.
Okay, so the entire discussion about the DPOX channel made me think like, hey, we also have monitors that do audio, and GPUs have kind of an attached sound device for that. Like, how does that work with muxes and switching?
Yeah, so vga-switcheroo does also handle, I kind of skipped over the whole audio issue as well because, yeah, vga-switcheroo does also have, and that's probably something I should add to the open design questions thing. So vga-switcheroo also does switching of the audio device as well. I probably need to look a little bit more into how that gets bubbled up to ALSA, and because you're right, you are switching the device that is connected to that audio output as well.
This is probably something for me. I was wondering, when reading the atomic commit thing, is it possible to make it atomic? Because if you, like, for example, when the first GPU gave out the display, the second one talks to it, and then for some reason couldn't talk to this display, what will happen then? Will it fall back to the first GPU?
Right. That's also something that is a design question I have considered and is open still to. Yeah, so there are a lot of failure paths, and one of the open design questions is what should the defined behavior be, for failure paths? Because what I've kind of envisioned is, there's one of the other open design questions is, if you'd go the atomic route, are you going to do a 1 commit or 2 commit approach? Are you going to do a switch away commit followed by a switch to commit, or are you going to do a single commit that then DRM core coordinates with both of the drivers to to kind of combine that? I think the single commit is probably easier for compositors, but it also opens more questions about like you have about what's failure going to look like if something depending on what stage that failure happens.
Yeah, because I feel like the receiving GPU, until it actually talks to the panel, especially if it's an external display, it doesn't have any idea to know if it can actually work.
Yes, it is a bit of a leap of faith. Yeah.
Yeah, and also like especially if like the DRM, not like the HD, like
the HD audio.
Yeah, not the audio, like the. If you play like a Prime Video or something like that, like the
HDCP.
HDCP.
Yes. Yeah, the other DRM.
Yeah, the other DRM. If that's involved, it's probably even more complicated.
Yeah. Oh, yes.
I was wondering if you have for HDMI, Muxing is complicated, but what about protocols like DisplayPort? Will it be possible to connect two streams to the same port, and then do the dynamic switching basically in software? Like you'd say to the panel, display this stream, and then display this other stream.
Yeah, I mean, DisplayPort is certainly complicated enough to maybe, I don't know. That's an interesting suggestion. I mean, we are talking about embedded DisplayPort for the common case for notebook internal panels anyway. I assume that, the engineers who design these systems, have decided that having a Mux is easier than trying to have, multiple devices connected on DisplayPort, but I don't know enough about DisplayPort to really untangle that fully.
Thank you.
Yeah. Okay, if there are any more questions, I think this is the last presentation for the day, so I don't know if the host comes back to do anything. Thanks.